right, so the next thing that we're going to talk about is something that should hopefully sound familiar, the mean and standard deviation of a normal distribution. The mean of a probability distribution is going to be our center or our balancing point. The difference is before we used X bar to represent our mean. Now we're going to use this new notation. We're going to use the Greek character mu. The standard deviation of our probability distribution. Again, like our standard deviation that we saw back in chapter 3, is going to have to do with how spread out our data is. And we're going to use a Greek letter instead. So we're going to use the Greek letter sigma. So before I start kind of going through those next couple of paragraphs, I'm just going to draw a little kind of cheat sheet table down here. Right? So we're thinking about mean, we're thinking about standard deviation. And what we saw in chapter 3, right, when we were thinking about mean, we used X bar. When we were thinking about standard deviation, we used S. Now we're going to use Greek characters. We're going to use mu for our mean. Again, it looks like kind of like a weird cursive-ish M. And then we're going to use sigma, which kind of looks like a zero with a little tail, to represent our standard deviation. So notation is definitely going to be essential as we start going through the rest of chapter 2 and the rest of chapter 6, section 6.2, and then we move forward into chapter 7, 8, and 9. Notation is going to be something that is going to be a big deal. It's something that's going to definitely be something that we want to focus on as we're going through. All right, so again, our mean is our balancing point or center. Our standard deviation measures the spread of our distribution by telling us how far away typically values are from the mean. The only way to distinguish among different normal distributions is by their means and their standard deviations, right? Because our normal distributions are all going to be unimodal and symmetric. So what's going to make them different are our values for our means and our standard deviations. Again, notation is going to be key as we're thinking about our means and standard deviations, so you definitely want to be paying attention to that as we continue going through these examples. Down at the bottom here, we have a couple of different pictures that are comparing some different things. So again, normal distributions are always unimodal and symmetric. In this particular case, notice that these two curves have different heights, right? Curves that have smaller standard deviations are going to be taller and skinnier. Curves that have larger standard deviations are going to be flatter and wider. So they're different heights because they have different standard deviations. However, notice that if we were to draw kind of a little dotted line down the middle here, right, it goes through the middle of both of our curves. So in that case, that means that these two particular normal curves have the same means, but they have different standard deviations. Right, so mean, again, is our center, and our standard deviation has to do with our spread. Right, how spread out is our data? Do we have a tall, skinny normal curve, or do we have a short, wide normal curve? Right, now, if we look at these other two images here, these guys are the same height. So these guys actually have these same standard deviations. So since they are the same height and shape, they have the same standard deviation, but they're going to have different means. Right? So what we see here, if we were to draw dotted lines down here, right, we have different means. My lines aren't exactly straight, but it's enough to make a point. Going back and kind of thinking about something else, I'm going to flip back up to the top of the page because what we see down here is a very common way of showing notation. So the distributions of women's heights is N64,3, and the distribution of men's heights is N69,3 in this case. What that means, that notation, Right? I mentioned notation was key. I skipped this little paragraph on purpose because I wanted to kind of see it in practice before we defined what it meant. So this notation, n mu comma sigma, represents a normal distribution that is centered at the value of the mean and whose spread is measured by sigma, the standard deviation. So that means looking at these, the distribution for the women's heights has a mean of 64 and a standard deviation of 3. And the mean of the men's heights is 69 and has a standard deviation of 3 also. Right? Again, our standard deviations were the same because the height was the same. So this notation is going to be something that we're going to see again in this chapter and in chapters that are going to follow it. The first number, the n, stands for our normal distribution, normal model, normal curve. And then the first number is always our mu, which is our mean, and our second number is always our sigma, which is our standard deviation.